things we are going to discuss in the next. That is because those functions involve along with the statistics. If you understand the statistics and then if you learn that one means it will be easy to understand, right? So let's start the statistics. Heading is statistics. Now, what is meant by statistics? Statistics means nothing but measuring and analyzing is called as statistics. Measure and analyze is called as statistics. You are going to measure the data, whatever the given data is that just you are going to measure, and based on the whatever you have measured, from that you are going to analyze the data, right? That is called as statistics. Now within the statistics, we are having two types. Two types of statistics are there. The first one is descriptive statistics. The first one is called as descriptive statistics. Now, what is meant by descriptive statistics? Descriptive statistics means nothing but analyzing the data, whatever the given data. Analyzing the given data means measure, analyze, or measure the statistical values. Measure the statistical values of given data. Of given data is called as descriptive statistics. Measure the statistical values. Statistical values means different statistical values we are having. Those things only we are going to discuss now. Measure the different statistical values of the given data is called as descriptive statistics. Simply to say, describe the data. Descriptive means describe. Describing the data. How we are going to describe means by using the statistical values, by measuring the statistical values. Describe the data by measuring the statistical values of, okay? Describe the given data, whatever the data, describe the given data by measuring the statistical values. By measuring the statistical value. I'm just combining the last two sentences. Okay. So what we are going to do means just we are going to describe the given data. So some data they will give. For example, let us take like this example. 1, 2, 3, 4, 5. Okay. We have to describe the data. Describing the data by measuring the statistical values. So we are going to describe this data. In this data, the minimum value is 1. The maximum value is 5. The average value is 3. Like this, I'm going to measure. And I'm going to describe about the data. Okay, in the given data, this is the minimum value, maximum value. This is the given range, like this, examples. So I'm going to just describe the data. For example, in this class, I'm having the online students and offline students. So total number of online students are 50. Total number of offline students are 30. Just I'm measuring. What I'm measuring? Total number of students. Count. I'm measuring the count. By measuring the count, I'm describing. Okay, these are the students. I'm describing my data. Just describing the data means here the students. I'm describing the students. How many students are there in the online? How many students are there in the offline? Right? And within that, how many students are girl students and how many of them are boy students? All these things are just describing. Means you are going to describe your entire data by showing the statistical values. In that statistical values means nothing but minimum value is a statistical value, max is a statistical value, average is a statistical value, count is a statistical value, everything is a statistical values. These all are statistical values, right? Just by measuring here, what you are going to do, just you are going to measure the data, means just you are going to describe the data, nothing else you are going to do. Next, we are having one more type of statistics called as inferential statistics. Second type of statistic is called as inferential statistics. Inferential means inferencing the data. Inferential statistics means inferencing the data. Now, what is meant by inferencing? Inferencing means nothing but estimating. Estimating. Inferencing means nothing but estimating. What you are estimating? Estimating the population data. Estimating the population data based on the sample data. Estimating the population data based on the sample data is called as inferential statistics. Okay. Statistics means measure and analyze, out of which descriptive statistics means describing the data by the statistical values, whereas inferential statistics means inferencing the data. Inferencing means called as estimating. Estimating the population data based on the sample data. Now your question is, what is population data and what is sample data? Okay. So let us see what is meant by sample data and what is meant by this, right? This is the first one. So just I'm saving this one. Right. Next, what is population? Next heading is population and sample. What is meant by population and what is meant by sample? Okay. What is meant by population and what is meant by sample? Now, population means entire data is considered as population. Entire data is called as population. Entire data is called as population. Now, what is meant by sample? Subset of population. Subset of population is called as sample. Okay. Subset of population is called as sample. Okay. Now, example, in this class, all the students, whoever has registered for this course, all students are called as population. If I consider all my students are considered as population. Within this, I'm selecting few students. Few students are considered as sample. If I select few students, they are called as sample. If I consider all the students, then it is called as population. Right? One more example, voters. If you consider all the voters in the particular constitution, if you consider all the voters, then it is called as population data. If you take a subset of that, it is called as population sample data. Now, do you know in the India we are having different states are there, right? What are the different states? What are the list of different states? Can you list the different states? Telangana, Andhra Pradesh. Like this, you are going to start, right? Are you going to say all the 29 states now? If you say all the 29 states names, then it is called as population data. If you say only 28 or so, then it is called as sample data only. If you miss one data also, it is considered as sample data. If you cover entire things only, it is called as population data. Got the point? Right? Population data means entire data. Now, we are going to estimate. Now, whatever I have told you earlier, inferential statistics. Inferential statistics is nothing but estimating the population data, estimating the population data based on sample. Based on sample data is called as inferential statistics. I already told you this one. Now, what is meant by this? Example. Why we have to estimate the populations are already population. All the students are in front of you only. Why you have to estimate? Now, today, all the students are there. Tomorrow, day after tomorrow, some days, some students will be absent, right? Every day, all the students will not present. Now, for example, let us take like this. I want to analyze the feedback. Who want to analyze, miss? Here, Naresh sir. Naresh sir wants to analyze the feedback of students. Feedback of the students of 6 p.m. batch. Miss, your batch, he wants to analyze the feedback. So to analyze the feedback, what he is going to do, miss, first he is going to color the feedback. Okay. So for analyzing this one, first we have to color the feedback. Okay. Now let us take this example. Now, when I'm collecting the feedback, when I'm trying to collect the feedback from all the students, okay. Now, are we going, for example, I asked you to give the rating out of 5. Okay. One student has given me 4.9. One student has given me 4.85, 4.92, 5, something out of 5. Anything as per your choice. Whatever the rating you feel out of 5. I ask you to give out of 5. Now, different students has given the different rating. Now, for this particular course at 6 p.m., total 100 students has enrolled. Assume that total 100 students are enrolled. Now, if I get the feedback from all the 100 students, and if I take the average of that one, then it is called as population average, population data average, because I have considered all the 100 students and I have taken the average of that. Now, out of 100, 99 students only have given. One student has not given. Only 99 has given. Then I am calculating the average on that. Now it is called as sample average, not the population average, right? Now in the real life, if I ask the students, for example, I have sent an SMS. In that SMS, there is an option called as please rate the give the feedback out of 5. What is that one? For each total 5 questions will be there. Satisfactory or not satisfactory. For each of the question, there will be multiple options. So you have to select, and there is a questionnaire form, and I'm going to send that one to your mail and your WhatsApp or to the SMS. I have sent the different sources. Now, out of 100 students, how many of them will reply in this class? If I send to all 100 students, miss, if everything goes fine, maximum 30 students will reply. Remaining 70 students will not even reply also. They will see, but they will not reply also. They will not give you that one because it is not mandatory. But if I say that if out of these 30 students, whoever has participated in this, they'll give, for example, participation certificate, miss. They don't know what is the meaning of certificate, but okay, certificate is the word is there. Okay, certificate is word is there. Okay, let us click on that. Freshers, they don't know anything. They'll click on that. Okay, some people they'll click on that. Miss, in order to get the data, we have to give something to the people. Otherwise, they'll not give the data. Right? Now, out of 100 students, if I am getting from 30 students, and from these 30 students, I have got the average rating as 4.9 out of 5. How many students has given? Only 30 students. This is the average of 30 students. Now, using this one, I'm going to estimate the population average. Based on the sample average, we are going to estimate the population average is called as inferential statistics. Is the point is clear now? Estimating the population data parameter, whatever the parameter, that is mean parameter, minimum value, whatever it is. You are estimating the population data based on the sample data, then it is called as inferential statistics. Now, out of 100 students, if all the 100 students has given the rating, and you have calculated the average of all the 100 students, then it is called as population. Then no need to do separately inferential statistics. No inferential statistics. Directly, we can conclude everything. But in real life, it is not possible. Because, for example, iPhone is there. As of now in the market, iPhone 14 Pro is there. And Apple company wants to launch the iPhone 15 Pro. Apple company wants to launch the Apple 15 Pro. I mean, 15 series. Okay, 15, normal 15 and 15 Pro, 15 Pro Max, whatever it is. So they want to launch the 15 series. Now, when they want to launch the 15 series, first they want to collect the feedback, whoever are using iPhone 14. And based on the feedback, in that positives will be there, negatives also will be there. So every phone will have some positives, some negatives. So now, whoever are using iPhone 14 Pro, they'll have some kind of Apple ID. that is mail ID. One ID will be there, or mail or phone number, which is attached to that. So let us assume total iPhone users are 1 lakh users are there. Till now, we have sold 1 lakh iPhone. Example, I'm taking an example, 1 lakh. Whether it is through Flipkart or through Amazon, through offline stores or through Apple stores, whatever it is, total 1 lakh products has been sold till now in the India. Now, within this 1 lakh units, now we want to analyze the data. Now, we have sent an SMS for all these 1 lakh users. Please participate in the survey. If you ask to participate in the survey, now out of these 1 lakh people, how many will give the reply? Means 10,000 or 15,000 people only will give the reply. 10 to 15% only will get the reply. You will not get the from all the 1 lakh users. See what the SMS they are going to send. Please share your valuable feedback. Please share your valuable feedback so that our company product will be improved in the further series, and we are going to get the better product in the Apple 15. They are going to send one SMS. Genuinely, they are sending. How many of them will give the reply? Means 10,000 or 15,000. For the genuine thing, only 10,000 or 15,000. But the same SMS this time, instead of saying valuable feedback or nothing like this, please participate in the survey. Please participate in the survey. The lucky people will get 3 nights, 2 days at Goa, at the rate of Goa. If they give like this, now earlier 10 to 15,000 you will get the replies. Now 30 to 40,000 you will get the replies. Genuinely, if they ask that, please share your feedback so that we'll improve our Apple 15 means, none of them will give. But if I say that too, some good pictures of Goa pictures, if you keep, and that to beach, related to beach, whatever the Goa beach pictures are there, that we share to the miss, many of the people will be interested and they'll participate in the survey. This is the actual fact. So in the market, okay, in the real-time industry, whoever wants to work on the survey, whoever are working on the survey to collect the data they will not get the free of cost. They have to spend the money. That too, in the market, getting the population data is simply impossible. Out of 1 lakh users, 99,999 replies if you get also, then it is still considered as sample only. Population means entire data is considered only as the population. So in the real life, getting this population data is impossible. So in real life, we'll work only on the sample data. Based on the sample data only, we'll estimate the population data, right? So for example, in a particular conjugation, in the particular conjugancy, like MLA, like let us take in the Hyderabad Khairtabad is there. Okay. Now in the Khairtabad, which party will win? Either BJP or TDP or Congress or whatever the other parties. So which party will win? We know that exit poll survey, right? What is meant by this exit poll survey? They are going to estimate this party is going to win. How they are going to do this one? Once polling is done, next day itself, they are going to give this one. Next day itself, they are analyzing, and next day itself, they are giving that in this area, this person will win. Overall, Congress will have this many seats. Overall, BJP will have this many seats. TRS will have this many seats. They are estimating. How they are estimating means, in the every polling center, they'll collect the data from few people. Okay. So whoever has casted their vote, and they'll come outside from the polling booth, right? Some survey team will be there. They'll ask in terms of to whom you have casted your vote. We are going to say that I have casted my vote to TRS, or I have casted my vote to BJP or something. We are going to say, right? They are going to note down that one. Okay. Some people will say that, okay, I will say for you what you will give for me. Okay. And they'll take the money. And after taking the money only, they'll tell the vote to whom they have casted their vote, like this. So once they'll get the data, that too, they are going to get the entire data. Means whoever has casted around, for example, in that area, particular area, 20,000 voters has voted. They are going to get from all the 20,000 voters? No, just a sample of 200 or 250, something like that. And based on that, they are going to analyze. Right now, here let us take like this. Exit poll survey in a particular area. I know that, for example, BJP is going to win. Okay. But BJP against parties will be there, right? Like example, TRS. Assume. Now, this particular party is having one news channel. Every party is having news channel nowadays. Now, this particular party is having a news channel. This party also knows that already this news channel also knows that it is going to lose in that particular area. But still, it will project that TRS is going to win. Why? Because they will collect the data only whoever has told the answer as TRS. Only those records, they will write that one. Whoever has told the BJP, hey, go away, will not write. They will not even write also. They will not even collect the data also. Officially, they will show whatever the data they are having. Every person has told TRS only, they will collect the data. They will collect the data in that way, which is called as bias. Bias means partiality. These things are possible if you are working as a data analyst, or if you are working for a particular company where that company is already with respect to one-sided, and you have to collect the data in that way, you have to analyze in that way, and answer also fixed. You have to project TRS only should win. If you are working for BJP channel means you have to project BJP should win. In that way, you have to analyze. Answer also fixed. Only in that way, you have to play the game. Right? Now, but in the IT industry, if you are working on the data means, will not work on the biased. Randomly, we are going to choose the data. Randomly, we are going to select the sample and we are going to work on that. So where the sampling, how we are going to select the sample means randomly. One way is randomly. One way of selecting the sample is non-random. Random sampling means randomly you are going to choose. For example, in this class, if I want to take the feedback means randomly, I may ask any student. If I want to non-random means who are sitting in the first bench, who will always shake their head. Only those people will ask the feedback. Then it is called as non-random, right? Ignoring the last bench people or whatever the things. So then it is called as non-random, or which is also called as bias sampling. But in the IT industry, particularly in the IT industry, whatever the projects we are going to work, it is only on the random sampling. Okay, is that clear? So based on the sample, we are estimating the population is called as inferential statistics. Why we have to do this one? In the interview, they'll ask you what is meant by inferential statistics and why you have to work on the sample data. Who asked you to work on the sample data? Work on the population data directly. Okay, give the population data. I will work on the population only. Why to work on the sample? If the population data is available, none of the person will work on the sample data. But from where you will bring the population data? It is highly impossible. Okay. For example, you want to collect and you want to analyze tomorrow what would be the temperature in Hyderabad at 12 o'clock. Okay. At exactly 12 o'clock, what would be the temperature? You want to estimate. And you have got that data, last 1 year data at exactly 12 o'clock. Last 1 year data means sample data only, right? Last 2 years data also sample data only. 2023 years data, if you are having, then it is called as population data. Now we are in the 2023. In the year of 0001, that is 1 year is there, right? In that year, what is the temperature at Hyderabad at 12 o'clock? If you are having that data, then it is called as population data. That none of them can bring. We can also never work on the population. That is highly. So in real life, we'll work only on the sample data. Collecting the population data is highly impossible. Okay. Sir, for example, you are having population data and you are analyzing the population data only. Assume that. Let us take a case. Then no need of inferential statistics. There is no concept of inferential statistics, only descriptive statistics. If you are having the entire population data, no inferential statistics, delete. Inferential statistics is not applicable. Inferential statistics is applicable only when we are working on sample data and we have to project the population data. Is that clear, guys? Got the point? What is the difference between the sample and okay? what is the difference between a sample and population, and what is the difference between descriptive statistics and inferential statistics, and at the same time, what is meant by random sampling and what is meant by non-random sampling. Is everything is clear? These are the 3 points which we have discussed. Exactly. That is called as cross validation. If I change the data, answer will change. You are asking the same question, right? So as randomly you are choosing, if you choose a different data, you'll get a different answer. If you change the different data, you are getting a different answer. That we are going to work on the cross validation. Cross validation means by changing the data, how my model is performing, how my machine is performing well. That is called as cross validation. Okay. Now, once again, first we have seen what is meant by statistics. That is measure and analyze. Different types of statistics. That is descriptive statistics and inferential statistics. Descriptive means it is going to describe the data. Inference means it is going to estimate the population data based on the sample. Next, what is meant by population and sample? Population means entire data is called as population data. Part of that is called as sample data. And next, we have seen the sampling techniques. 2 types of sampling techniques are there. One is called as random sampling and one is called as non-random sampling. Random sampling means randomly you are going to choose the data is called as random sampling. Non-random sampling means having some kind of partiality, which is also called as bias. Biased sampling. Non-random sampling is also called as biased sampling. Biased means on one-sided. You are one-sided, right? So these are the things which we have discussed. Now, let's move on to the next one. Now, statistical analysis means measuring the statistical values. So, for measuring the statistical values, we are having different business moments. Okay, business moments. What is meant by business moments means the values, the measure of the values we are going to say based on the business moments. We are having first business moment. First business moment. Second business moment. Third. And fourth. 4 business moments are there. First, second, third, and fourth. The first business moment is called as measure of central tendency. The first one is called as measure of central tendency. The second one is called as measures of spread. Okay, measures of spread or measures of dispersion means how my data was distributed, dispersion. Third business moment is considered as third and fourth. Both of them measures the shape. Third and fourth, both of them measures the shape of the data. Measures the shape of the data. Measures of shape. They are considered as measures of shape. Third and fourth, both of them. One will measure widthness and one will measure the height. Okay, let us see one by one. The first business moment is nothing but measures of central tendency. Second business moment is nothing but measures of spread or measures of dispersion. Third business and fourth business moment relates to measures of shape. Now, let's start with the first one, which is called as measures of central tendency. Measures of central tendency. Okay, let's start first. Is that clear, guys? Just their headings only. You'll understand one by one. Okay, just I have written only the headings. From the headings, you will nothing understand. You will understand one by one clearly. Now, the first one is measures of central tendency. Let us start with the first one is measures of central tendency. Now, within the measures of central tendency, we are having the first one is called as mean. Mean means nothing but average. Average of the given data. Average value of the given data is called as mean. In maths, it is called as average. In statistics, it is called as mean. Both are same. Okay, average value of the given data, right? Whatever the data they have given, just you have to calculate the average value is called as mean. Example, let us take like this. 1, 2, 3, 4, 5. Mean is nothing but your mean value. Your mean is equal to sum of all the values. Mean is equal to sum of all data points. Sum of all data points divided by total number of data points. Divide by total number of data points. Mean is nothing but sum of all data points divided by total number of data points. Sum of all the data points. Sum is always given by the sigma symbol. Symbol is sigma. Sum. This symbol indicates that sum. You are doing the sum. Whatever the values. If it is errors, okay, you are measuring the sum of the errors. If it is distances, sum of the distances. If you are calculating the sum of the values, whatever the things, sigma indicates sum. Total number of data points are indicated by hash. Symbol is hash. Wherever you see the number hash, it indicates that number of. Okay. For example, in this class, how many number of students are there, miss? Just I can write like this, hash students. What is meant by hash, miss? Number of students. Okay. So hash symbol, right? Now, coming to the thing, this one, measure mean. Mean is nothing but sum of all the data points divided by total number of data points. That is, sum is sigma. Sigma of x divided by total number of data points is n. So this is x. Column name is x. Sum of x data points. Whatever you are having in that particular column, sum of all the data points divided by total number of data points. Now, total number of data points. Total number of data points is equal to n or small n. When it is n, miss, if it is population data. If it is population data, it is n. If it is sample data, it is small n. If you are working on the sample data, then we have to represent by small n. Whenever you are working on the population data, you have to represent by caps lock n. Okay. And similarly, now population mean. Population mean is equal to population sum of data points divided by population data, total number of population data, and which is given by mu. Mu is equal to sigma x divided by n. In this case, 1 plus 2 plus 3 plus 4 plus 5 divided by 5, which is equal to 3. Assume the data is population data. Assume the given data is population data, then population mean is this one. Okay. Population mean is given by the symbol called as mu. Right? Now, coming to the sample mean. Okay. Population mean was given by the symbol called as mu. Mu is nothing but sigma x by caps lock n. Sample mean is given by x bar. Sample mean was given by x bar. Sigma x divided by small n. Formula is sigma x. Again, sum of the data points. Now, this time the sum of data points are sample data points. Sum of all the sample data points divided by total number of sample data points. Is that clear? So let me write in this way. Population mean, which is equal to mu, is equal to sum of all population data points. Sum of all population data points. whatever the population data values, data points means data values. Sum of all the population data values divide by total number of population data values. Okay, which is nothing but mu is sigma x divided by n. For the sample mean, now coming to the sample mean, which is x bar, you have to write instead of population word, sample word. That is sum of all sample data values divided by total number of sample data values, which is nothing but x bar x sigma x divided by small n. Okay, this is called as population mean and sample mean. What are the data points you are collecting? First, you have to see whether it is a sample data or a population data. Sir, how I can know whether it is a given data is a sample data or population data? Miss, in the question, they'll mention this is a sample data. In the real life, in the business problem, means whenever you are starting the project, before to the project, first we are going to understand the data, whatever the data they have given to us. At the time itself, you'll understand all these things, whether they have given a sample data or whether they have given the population data. And according to that, we are going to work. Okay. Before working on it, first we have to understand the data, then we will start the work. Directly will not start the work. If you are considering like a statistics exam or the questions, in the question they will mention for the given sample data, calculate the mean. Then for the given sample data, calculate the mean means automatically we have to calculate sample mean only. Right? Population mean we can't calculate based on the sample data, right? Is that clear? Mean means nothing but average of the given data. Okay, average value of the given data is called as mean. Next one, in the measures of central tendency, the second one is called as median. The second one is called as median. Once mean is completed, second one is called as median. Median means center position value. Center position value, whichever is in the center position. Okay. Okay. Center position value of a ordered data. Of a ordered data. First, you have to make the given data in the proper order. In that order, whatever the center value is there, that value is the median value. If total data points are odd number, then median is equal to n plus 1 divided by 2. That is the center position value. Okay. Median value is nothing but n plus 1 divided by 2. That is median is center position. Center position is equal to n plus 1 divided by 2. Center position is equal to n plus 1 divided by 2. If the total data points or even number of data points are there, then median is average of center two values. Average of center two values. Okay, median is average of center two values. Now, let us take an example. Let us go with an example. Okay, example is 1, 5, 2, 4, 3. The data was this one. This is the data. Now, what we have to do? First, this data, this is the given data. This given data has to be converted to a ordered data. Whenever you have to calculate the median, first it has to be converted to order. Then only we can calculate the median. Without converting to order, we should not calculate the median. So first we have to convert to a order, either ascending or descending. Choice is yours. Anything of your choice. So I'm going to take the ascending order. 1, 2, 3, 4, 5. Since the total number of data points are odd, means 5 data points are there. Now center position value is nothing but 5 plus 1 divided by 2. That is nothing but 5 plus 1, 6, 6 by 2, third position is my center position value. Whatever is in the center position, in this position, whatever the value is there, whether that is 3 or 3.1, 3.2, anything in the center position, which is in the center position. I want the position. Here the word of position is most important. You are not focusing on the value. You are focusing only on the position. In that position, whatever the number is there, you are focusing on the position. Now, for example, I'm having like this 1, 5, 2, 4, 3, and 6 is there. Then ordered data. Ordered data is 1, 2, 3, 4, 5, 6. Now, center position in the center. Average of these two is nothing but 3 plus 4 divided by 2, 3.5. This is the median value. Okay. In this case, this is the median for this data set. For this data set, this is the median. For this one, this is the example. And for this one, this is the example. Is that clear? So median means center position value of a ordered data. First, we have to convert to order. And after converting to order, which is in the center position, that value is considered as median. Whatever the value. Whatever the value. We are not focusing on the value. We are focusing only on the center position. Right? Sir, for example, I'm having a data set like this. 0, 1, 2, 3, 400, 500, and 600. Something. In this case, what is the median, miss? 3 only median. We are not calculating the average. We are calculating the position. In the position, given position, what is there in the center position? Okay. Means here, if there are some five chairs are there and 5 persons are sitting in the 5 chairs, who is sitting in the middle? Some person will sit in the middle, right? Whoever the person is sitting in the middle position, he is called as median. His name is not important. His designation is not important. His things are not important. Nothing is important for us. He is sitting in the middle chair. That is only important. For median, only the center position. What position it is there? In which position is there? So whatever the value is there in the center position, that value is considered as the median value. Right? This is called as median. Now coming to the next one. Median is clear. Mean and median. Both are clear. Now the third one. In the measures of central tendency, we are having the mean, median, and the third one is called as mode. The next example is called as mode. Sorry, not example, concept. Next concept is called as mode. Third one, mode. Now, what is meant by mode? Mode means most repeated value. Most repeated value, which was repeated more number of times, that particular value. Right? Now, most repeated value is called as mode. Example. Multiple examples. We are not going to discuss only one example. I'm not going to conclude the topic on one example. I'll explain multiple examples. Whatever you are going to get in your brain, the questions, we'll see one by one. Once I say that mode is completed, then you ask the questions. Okay. Now, example number 1. I'm having the data like this. 1, 1, 1, 2, 2, 3, 4, 5, something. Now, in this case, 1 was repeated for 3 times. 1 repeated for 3 times. 2 repeated for 2 times. Remaining everything are repeated for 1 time only. Which is most repeated out of all of them? 1 is more number of times repeated. So 1 is called as mode in this example. Example number 2. Same 1, 1, 2, 2, 3, 4, 5. Now 1 is repeated 2 times. 1 was repeated 2 times. 2 also repeated 2 times. Both of them are repeated 2 times. Now, what is the mode means? Here, both of them are modes. both 1 and 2. Both 1 and 2 are modes. If both of them repeated same number of times, then both 1 and 2 are called as modes, and this data is called as bimodal data. Bimodal means two modes are there. In the given data, two modes are there. One is 1 and one is 2. Right? Now, example number 3. 1, 1, 2, 2, 3, 3, 4, 5. Means 1 was repeated 2 times. 2 was repeated 2 times. 3 also repeated 2 times. Everything. Now everything are equal. For example, 2 was repeated for 3 times means blindly 2. Which is most repeated, that is clear means that is 1. Simple. But here in this case, 3 are there, 3 repeated, and the 2 same number of times repeated. Now what is the mode means? 1, 2, 3, all of them are modes. 1, 2, 3, all of them are modes, and it is called as multimodal. Multimodal distribution. What is meant by multimodal distribution? Means multiple modes are there. Means a data set can have how many modes? 1 to infinite. Anything can be there. Infinite number of modes is possible. Right? Now this is called as unimodal. Uni means only one mode is there in the given data. Unimodal data. Bimodal data. It is multimodal data. Sir, in the median, you have taken the average, right? 1 and 2. Average of 1 and 2. And for a median, center 2 values are there, means you have taken the average. Similarly, you can take here also average of 1 and 2 now. Why you are taking two modes? You can take 1 and 2, right? Now, the question is, for example, for median, in the median or in the mode, now in the median, for example, I'm having a text data. Text data is there. For example, text data, let us take like this. Suresh. One name is Suresh. Second name is Suresh. And third one name is Mahesh. Next one is some kind of Krishna. Something we are having. Okay, Suresh, Mahesh, and Krishna. Now, you have to calculate the median for this data. What is the median of this data, miss? How we can calculate? What is the order? Who is low, who is high? They're just names only. Is Krishna name is better than the Suresh name? Or Suresh name is better than the Mahesh name? Nothing like that. There is no order. For the text data, we can't calculate the median. But the text data, we can calculate the mode. How we can calculate the mode? Because it is most repeated value. Which is most repeated? That one only, right? So here Suresh was repeated more number of times. Mode is the Suresh. So for text data, we can calculate only the mode. For the text data, we can't calculate the mean. We can't calculate the median. Both are not possible. For text data, mean is not possible. We can't take the Suresh plus Mahesh plus Krishna divided by 4. We can't do that one. Sum of the data points divided by total number of data points. We can't apply this logic for this data. Can you apply that logic, that data? Suresh plus Mahesh plus Krishna divided by 4, which is Ki. Like this, are you going to say? Nothing like that, right? We are not going to say like that. Nothing is possible for this. So mean is not possible. Median is not possible. None of them is possible. But mode is possible. But same mode, if you take the average, then how we can calculate the average of center to here? How we can calculate? So that is the reason the mode was created with most repeated one. And if you are having two of them was repeated for same number of times, then it is called as bimodal data. Sir, I'm having a data set like this. 1, 2, 3, 4, 5. This is example number 4. In this data, none of them was repeated. No mode. No mode. Not even one is there, right? Minimum one should be repeated. That whichever the value got repeated, that one only is considered as mode. Not repeated means it is not called as mode only. No repetition is there means none of the value is called as mode value. Mode means minimum one time should be repeated. Repeat means same time should be there. That is called as repeat. So if the same one is there one more time, then only it is called as. In this case, no mode. There is no mode. Zero mode. Nothing is there. Don't say zero. Zero means that is also a different value. You have to say no mode. Don't say zero mode. Zero mode means answer is zero. Huh? For example, you are having 0, 0. Then what is the mode means? Zero mode. This is zero mode. So don't say zero mode. Say that no mode. Is that clear? Mode means most repeated one is called as mode. Mean, median, and mode. These three of them comes under measures of central tendency. Is that clear? Now, why they have kept the name as central tendency? Because they'll focus on the central value. Average value will focus on the center value. Median also will focus on the center value. Then mode also will focus generally in the center value. How, sir? That we'll see in the future. Once we understand the normal distribution, then automatically you'll understand. Okay. Why the name they have created measures of central tendency means these values, whatever the mean or median or mode, everything focus on the center value. So that is the reason central tendency. So measures of center, simply to called as measures of center. They'll focus on the center value. One is focusing on the value. One is focusing on the position. If center value you want, then it is called as mean. Center position value you want, it is called as median. Now, what is the difference? Question is, what is the difference between mean and median? Mean is called as center value. Whatever is in the center, that value is called as mean. Median means center position value. In center position, whatever the value is there, that is called as median. They both are different. Okay, whatever is in the center position. Example, let us take like this. 1, 2, 3, 4, 5. If I consider like this, now in this case, what happens means 1, 2, 3, 4, 5. Mean is equal to 3 because you are going to get 15 total. 15 by 5 is 3. Median also 3. In this case, both are equal. But let us take one more example. 1, 2, 10, 14, 18. Now, in this case, what is the mean value? Mean value is 1 plus 2, 3, 3 plus 10, 13, 13 plus 14, 27, 27 plus 18, 35, 35 divided by 5, which is equal to 7. This is called as average value. Okay. That is how only. Yeah. 18 plus 14, what is the value? 32. 32 plus 10, 42. 42 plus 3, 45. Not 30, 40. Okay, sorry, my mistake. Okay, 45 is 9. The average value is equal to 9. What is the median value here? It is equal to 10. Okay, so one is mean value, one is median value. Is that clear? Got the point, guys? Yes, 45 divided by 5, which is 9. Mean value is average value. What is meant by average value? Average value is center. It is in the center value. Center value. That is called as center value. Mean is called as center value. Median is called as center position value. That is the difference. And in the certification, if they ask you what is the center position value is, don't calculate the center value. Center position value is median. What is the center value is average. That is mean. Clear, guys? Average and median. Now, sir, you told that symbol for the mean and that too for the population data. For the population data, the symbol was given as mu, and for the sample data, it is given as X bar. And the formula is sigma X divided by caps lock N, and this is sigma X by small n. Now, what about the median? What is the symbol? There is no symbol for this. What is the symbol for mode? There is no symbol for this. Since there is no symbol, I have not told anything. There are no symbols for the median or mode. The symbol is only available for the mean. Is that clear? Now, then how we have to apply that median of the population data, or if they ask you us answer, then just you have to write median is equal to 14.9 something. What are the answer that you have to write like this? Whereas mean means you have to represent by mu is equal to. Is that clear? Now, so mean, median, and mode. Now let us move on to the next one. Is the concept is clear, guys? That is measures of central tendency, mean, median, and mode. Now let us move on to the next one called as measures of dispersion. Measures of dispersion or measures of shape. Measures of spread. Measures of dispersion or measures of spread. Spread means how your data has spread. Right? Measures of dispersion or measures of spread. This is the second one, second business moment. Now in this, what we are going to measure is one, range. So before range, minimum value. First one, we are going to measure the minimum value. 2, maximum value. Minimum, maximum. 3, range. 4, deviation. 5, variance. 6, standard deviation. Seven, percentile. 8, quartile. 9, interquartile range. Interquartile range, which is given as shortcut is IQR. Right? And 10, mean deviation. 11, mean absolute deviation. Mean deviation, mean absolute deviation. These are the total 11 as of now. Right? So this all comes under measures of dispersion or spread. Concept will be dead easy. Nothing will be there. Numbers will be 11, but matter will be nothing. Okay. Let us see one by one. Okay. Let us start one by one. The first one is minimum value, maximum. Let us take by an example. Just to focus the example, you'll understand all the concepts just in 5 minutes. Dead easy, right? So let me take an X, some X of 1, 2, 3, 4, 5. Sir, why you're considering 1, 2, 3, 4, 5, sir? For calculation purpose, it is easy. If I take big numbers, I have to open the calculator. Why I have to take my complex example? Why I have to get confused? If I go with the simple example, concept will be very simple, right? Now, for this X, this is the column where I'm having total 5 values. For these 5 values, first one is called as minimum. Don't write simultaneously along with me. Just understand so that it will be easy. First one is called as minimum. Minimum is starting value, from where it is starting. The entire order data, ascending order data, the starting point of the ascending order data. Okay. The starting point of the ascending order data is called as minimum value. Minimum is least value. Here it is 1. Everyone knows minimum value, right? I don't need to explain much on this. Next one is called as maximum value. Maximum is highest value of the entire order data, the maximum value. So whenever I ask in the coding for this entire data frame, what is the maximum value? First, it is going to take the list.sort. It is going to apply the sort. After applying the sort, it will get the ascending order. Within the ascending order, whatever the answer is there in the -1, that is in the last portion, that one is the maximum value. Whatever is in the starting portion, that is the minimum value. This is the backend code of that one. Whenever I write the code in the pandas or in the NumPy or in the list or in the core Python, this is the backend code, right? First, they are going to do the sort. After that, the starting portion value, ending portion value. Starting portion value is considered as minimum. Ending portion value is considered as maximum. Next one is range. Range is nothing but your maximum value minus minimum value is called as range, which is nothing but 5 minus 1, 4. Means all the data points are within the range of 4. The entire data was spread between 1 to 5. A range of 4, it is spread. It is neither having more than 5. It is neither having less than 1. The entire data was spreaded within the 4 data points, 4 value. 4 means the total value of 4 means the difference between the highest to minimum value is considered as the range, right? That is called as range. Now, coming to the fourth one, which is called as deviation. Deviation means how much the data was deviated from the mean. Deviation means how much the data was deviated from the mean. So for this data, first you calculate the mean value, that is 3. Okay, let us assume this is a population data. For population data, population mean, which is mu is equal to 3. Now, x minus mu, I'm calculating x minus mu. X minus mu is nothing but this particular data, how much it is deviated from the mean? Minus 2 distance it is deviated. This one was deviated from the mean, minus 1. This is deviated from the mean, 0. This is deviated from the mean, plus 1. This is deviated from the mean, plus 2. This is called as deviation. Deviation means how much it is deviated from the mean value. It is called as deviation. Is that clear? Deviation means how much it is deviated from the mean value is called as deviation. Now, for example, in this class, I have kept an exam and all the students has got the marks. The average marks is 75. Average mark is 75. Now, one student has got 62. What is the meaning of the student has got 62? Means he is deviated 13 marks less than to the average student. When compared to average student, he is having 13 marks less. One student has got 79. When compared to average mark, he is having 4 marks more. Either the deviation will be left side or right side. Anything will be there, which is called as deviations. Deviations means how much the data is deviated from the mean is called as deviation. Okay. How much the data is deviated from the mean. Data deviated from the mean is called as deviation, which is given as x minus mu. Each and every data point. Now, next one is sum of deviations. Sum of deviations means whatever the deviations are there, you are going to do the sum. Sum is always equal to 0. It is always 0. Always. Because you are going to measure from the average value means left side how much distance is there, right side also same distance will be there, right? Take any data points of your choice, whatever the data points you want. In the entire world, you select whatever the data points you want. Take 5 or 6 or 7, whatever you want. Now, for this data points, just calculate the average value. Average value means what is the meaning of the average value? Center values. From the center, how much left side data points are there? Right side also should be same only, right? Obviously. This number means, for example, you are having the only 2 data points. The data points are 10 and 11. Assume. What is the average of these two? 10.5. 10 point from the 10.5 left side 10. How much distance is there? 11 also same distance. That is the reason it is called as average. Otherwise, why it is called as average? What is meant by average means center value. From the center value, how much you are having the deviation towards the left, the same deviation will be towards the right also. If you do the sum of the both of them, minus plus plus will be 0, equal to 0. Always the sum of the deviations will be 0. Okay. Now, next one is mean absolute deviation. Now, if you calculate the mean deviation, now what is the mean deviation? Sum of deviations. Okay. Now, what is the mean deviation? What I have told mean means nothing but sigma divided by n. Sigma of whatever the data. Here, nothing but x minus mu. Sigma of x minus mu is sum of all these things, which is equal to 0, 0 by 5, which is equal to 0. This is called as mean deviation. Mean deviation means sum of all the deviation points divided by total number of deviation points. You are calculating deviation points, right? So sum of all the deviation divided by total number of deviation, which is equal to 0. Is that clear? Up to mean deviation. If it is clear, write in the notes so that I will erase and I will write the next one. Yes, sum of the deviation is 0 means obviously why we are the mean deviation also should be equal to 0, obviously. Then why we are using the particular mean deviation? No, will not use. In life, we'll not use the sum of deviations, will not use the mean deviation. Both of them will not use because both of them is fixed answers, 0 only. No. Deviation and standard deviation both are different. We'll see one by one. And what is the reason why we'll not consider also? We'll see. Deviation means how much it is deviated from the mean. Okay. Now, let us take an example. Please, first you complete this one. If everything is completed, I'll write one more example and I will explain. Done. Now, let us take one more example. The one more example is Virat Kohli batting score, whatever the score he has made in the last 5 matches. Okay, Virat Kohli's last 5 matches runs. Let us take like this: 35, 42, 45, 48, and 20, something. Total is 7, 12, 20, 5, 9, 13, 17, 19. So let us convert this one to 30. So total is 200. Okay, total is 200. This is the total of last 5 matches. What are the Virat Kohli's batting score? Okay, now here, this is the runs. What are the runs he has made in the last 5 matches? Okay, the score is nothing but runs. Now, here these runs. Now, from the average, what is the average value? What is the average runs he has made? Average runs is 40. Now, in the first match, how much runs he is deviated from his batting average? -5. Second one, +2. Now, if you total the negative values, what is the total of negative values? -15. If you total the positive values, it is +15, equal to 0. Sum is always equal to 0. Now, here, if you observe, this is the deviations. In every match, he is having the deviation. Now, every match, certain deviation is there. What is the average deviation? 0. Average deviation is 0 means no deviation. Huh? For example, this Virat Kohli is like this. Let us take one more batsman. He has played first match 100. Second match, duck out. Third match, 10 runs. Fourth match, 20 runs. Fifth match, 70 runs. Again, total is also 200 only. In this case also, total is 200 only. Again, the average is also again 40 only. Now, in this case, what is the deviation for the first match? Means 100 minus 40 plus 60. This is -40. This is -30, -20 plus 30. Right? So now, if you observe this one, again the average deviation is getting 0. Sum of deviations is going to be 0, average deviation 0. Miss, this person also not having deviation. Huh? Both are not having deviations. Huh? So that is the reason why we'll not go with the mean deviation. Then what is the solution of this one? Solution is with respect to two options are there. One is convert your negative values to the positive values. All the negative values you convert to positive values and calculate the mean. How to convert negative values to positive? Two options. One is apply absolute. One is apply the square. Any negative value to be converted to positive is one is absolute, one is square. These are the two options. Now, what I'm going to do is first one, absolute. Now, what is meant by absolute deviation? Absolute deviation means first deviation for that absolute value, which is nothing but mod of x minus mu, is called as absolute deviation. Okay. Absolute deviation. What is meant by absolute deviation? First deviation. For this deviation, you're applying the absolute, is called as absolute deviation. So 2, 1, 0, 1, and 2. Now, what you are going to do? Average. You are going to take the average of these 5 values. That is, average means sigma by n of what? Absolute deviations. That is x minus mu divided by n, which is equal to sum of absolute deviations equal to 10 divided by 5, which is equal to 2. What is this is called as means mean absolute deviation. Mean of all the absolute deviations. Mean absolute deviation. Formula is sigma of x minus mu absolute divided by n. Is that clear? First you have converted to absolute. After that you have calculated mean. Mean absolute deviation. What is meant by deviation? What is meant by mean absolute deviation? Mean absolute deviation means what is meant by deviation? X minus mu is called as deviation. Okay. What is meant by absolute? Apply the absolute. What is meant by mean? Sigma by n. This is the formula. Mean absolute deviation. So now I'm going to calculate the mean absolute deviation for this data, and I have got as 2 because it is 10 divided by 2. Now, what is the second option I'm having is mean square deviation. Now, what is meant by deviation? X minus mu is called as deviation. What is meant by square? Yes, 6 by 5. 6 by 5, which is 1.2. Right? Now, mean square deviation. What is meant by mean square deviation? Deviation is x minus mu. Square means whole square. Mean means sigma by n. This is called as mean square deviation formula. How you have to calculate this mean square deviation? How to calculate the mean square deviation? First, for the given data, first we have to calculate the deviations. From that, we have to calculate the x minus mu whole square. That is minus 2 whole square is plus 4. Minus 1 whole square is plus 1. 0, plus 1, and plus 2, plus 4. Now, mean square deviation, that is x minus mu whole square divided by n is equal to 10 divided by 5, which is equal to 2. This is called as mean square deviation. Mean absolute deviation, mean square deviation. Why you have to do absolute? Why you have to do the square? Because if you go with the normal values, some of the negative values will be, some of them will be positive, and it will be nullified. And you're going to get every time the mean deviation as 0. That is the reason we have to select either mean absolute deviation or mean square deviation. Out of these two, we have to select. Now, out of these two, which one you have to select? That is the question. Okay. Which one you have to select? Which one? That is, one is mean absolute deviation, one is mean square deviation. Which one you have to select means we have to select mean square deviation. Why? That is the one of the most important interview question. Write in the notes. Why we have to select mean square deviation instead of mean absolute deviation? Write in the notes. Compulsory you have to write in the notes. Mandatory question. Right? Why we have to consider mean square deviation instead of mean absolute deviation? Why? Reason behind that is mean absolute deviation. Answer is mean absolute deviation is having the differentiation problem. Differentiation. Mean absolute deviation is having differentiation problem. Now, what is meant by differentiation problem? Differentiation problem. Now, what is meant by differentiation problem? The differentiation problem is nothing but d by dx of mod x. If you consider any mod x, if you consider, the answer is x divided by mod x. And at x is equal to 0, it is going to give the infinite answer. Whereas d by dx of, if you take any square term, then you are going to get 2x, and at x is equal to 0, the answer is a finite value. Now the question is, hey, who asked you to the deviation? Who asked you to the differentiation one? And why you are substituting x is equal to 0? First, why you are doing differentiation, and why you are substituting 0? Why you are doing this one? Because deviation generally we want the maximum value or minimum value. Which one is good? If less deviation is there, means good, or more deviation is there is good. That is minimum, clear, right? Less deviation. If our batting average, whatever the batting average, if all the scores are close to the batting average, that is a good batsman. He is a good batsman. If the deviations are very high, like Chris Gayle is there, one match he will play century, one match he will play duckout. When he'll play, he only don't know, right? So that person, whereas some other consistent players are there, they'll play minimum this much certain runs. We are having that trust on that particular player. Why? Because he's having the consistency. Means every time he'll play with respect to very close to the average. Whatever the average is there. Now, generally the deviation should be low. Deviation should be low or minimum. Generally the deviation should be low or minimum. For any data, any particular thing, if you want the low or minimum value, we have to calculate the differentiation, and at that we have to substitute at x is equal to 0. Then you will get the minimum value. For any particular equation, one equation is there. Y is equal to 4x square plus 2x plus 9. This is one equation. For this equation, what is the minimum value of y? Can anyone tell me? Substitute whatever the values of x you want. Substitute. In the entire world, you substitute whatever the values you want. What is the minimum to minimum value of y you are going to get? Minimum value is 9 only. Than 9, you can't get the minimum value. When you substitute x is equal to 0, that is the minimum value. If you take -1, you will get more value only. Or if you get something. Now, if you go with that, how you calculated that value means just based on the differentiation. First, we have to do the differentiation. That is dy by dx, 8x plus 2. And x is equal to 0 means the minimum value you are going to get is 2. That is the minimum value. For this equation, the minimum value is 2. Than that, you can't get the minimum value. If you substitute 0 also, 9 only you will get. If you go with -1, 4 minus 2 plus 9. 4 minus 2 is 2, 2 plus 9. 2 plus 9 is 11. So if you try with all the different values, the minimum value you are going to get is only 2 for this given equation. Than that, you can't get the minimum value. So for any data set, for any equation, if you want the minimum value, what we have to do is dy by dx we have to do. Now, if your y variable, whatever the equation is there, that equation consists of mod means you are going to have the infinite. If the equation is consisting of square only, you'll have the finite value. When you will get the finite value means if it is having square, if it is having modulus in the equation means you'll get the infinite value. That is the reason we'll not go with the mean absolute deviation. Reason behind that is this. Why we have to select mean square deviation means this is the reason. And this mean square deviation is also called as variance. This one only they created one more name called as variance. Why they can create with mean absolute error also, right? Mean absolute deviation also they can create. But the variance was given by mean square deviation by selecting the squares. Why they have selected squares only means differentiation problem is there in the absolute values. Why we have to do the differentiation means in order to calculate the minimum value. Why we calculate the minimum value means because deviation should be minimum for any data. The lesser the deviation, the better the result. Whether it is a deviation, whether it is an error, means, for example, whichever you are required, whether first you have to check whether minimum value required or maximum value required. Minimum value required means you have to do the differentiation. Maximum value required means no need to do differentiation. Whenever there is a minimum value, think that differentiation will come into picture. For any equation, for any given equation, minimum value is given based on the differentiation. Is that clear? Question is clear? So mean squared deviation is also called as variance. Now, there is a problem in the variance. There is one problem in the squared deviation also. Mean absolute deviation problem is there. Mean squared deviation also problem is there. What is the problem in the mean squared deviation means? For example, earlier, the example I have told is runs, right? One person has code with respect to 36, 34, 20, 30, total is 70, 120, 80. Okay, total 200 are there. Total runs is 200. Now, total you are having 200 like this. Now, for this 200, now if you calculate the deviation, that is 36 minus 40. Average is, what is the average value? Which is nothing but 40. 36 minus 40, which is minus 4 runs is the deviation. Minus 4 runs is the deviation. Now, whenever you are squaring of that one, minus 4 runs whole square, what is that one? 16 runs square is the deviation. Now, whenever you are applying the mean of that one, what you are going to get? Output, some value with the runs square. Means the units are also getting squared off. That is the problem in the variance or mean square deviation. What is the problem in mean square deviation? Means the units also will be squared. I don't want units to be squared. I want normal deviation only. I don't want the square of the deviations. Then what we have to do? Just we have to apply the square root for this. Apply the square root for this. That is nothing but a root mean square deviation. Root mean square deviation. Mean deviation means x minus mu. Square means whole square. Mean means sigma by n. Root means for entire thing, you have to calculate the root. Which is nothing but your square root of mean square deviation only. Square root of your mean square deviation, which is nothing but your variance. Square root of variance is called as standard deviation. This is the actual deviation. This is the right one. This is the finally the best one. That is the reason it is called as standard. The reason behind that is standard is this one. This is the standard one. It is clear now? From where you got the formulas step by step. Instead of directly by hearting the formulas and taking the variance is x minus mu whole square and substituting the values. Why? What is the reason? Why they have created like that and what is the reason behind that? Everything step by step. If you understand means no need to by heart. Otherwise, we have to remember the formulas. Right? Standard deviation means square root of variance. Variance means nothing but square root of x minus mu whole square divided by caps log n. This is called as. So variance is given by the form sigma square. It is given by the symbol called as sigma square. And this is given by the formula sigma. Because square root of sigma square is sigma only, right? This is given by sigma. This is given by sigma square. Symbols. For minimum value, maximum value, range value, deviation value, mean deviation, none of them is having the symbols. Only variance is having the symbol. At the same time, standard deviation is having the symbol. Is that clear? Now, clear guys, variance and standard deviations, step by step. Now, variance, population variance is given as sigma square, which is nothing but sigma of x minus mu whole square divided by n, because you have considered the population mean, population data. And n also population, mu also population. Similarly, population standard deviation, which is nothing but sigma, was given by square root of sigma of x minus mu whole square divided by n. From where you got formula also I have explained step by step how you got the formula and how they have created that one. Everything we have seen step by step, and why we have to take only square in that instead of considering the absolute. Why we have considered the square also I have told you, right? Now, similarly, we are having sample variance. And the sample variance is given by S square, which is equal to sigma of x minus x bar. Sample mean is x bar whole square divided by sample data small n minus 1. You have to take minus 1. Why minus 1? This is important question. One of the most important question. 100% again guarantee question within the statistics. And this is my favorite question. In the interview, I will ask 100%. I will ask why we have to consider n minus 1 in the sample. Simply you can consider n only, right? Small n. Why you have to consider n minus 1, right? Similarly, standard deviation. Sample standard deviation is given by formula small s square root of x minus x bar whole square divided by small n minus 1. This is sample standard deviation, sample variance and sample standard deviation. If you observe, the population mean was given by the symbol called as mu. Mean is given by the mu, which is sigma x by caps lock n. And the same mean here was given by x bar, which was given by sigma x by small n. If you observe this one, all these symbols are the Greek letters. For population data, Greek letters will be there. For the sample data, English letters will be there. The symbols will be English letters. All the population data will be represented by Greek letters. All the sample data will be represented by English letters. S square, X. These are represented by Greek letters. Sigma square and mu, all these things. Okay, this is not an interview question. How they will be represented. Example only I'm saying. Okay. Now the question is, why we have to consider n minus 1 in the sample? Why we have to consider n minus 1 in the sample? Write the question in the notes. Question. Why we have to consider n minus 1 in the sample? Question number 1. Question number 2. What is this n minus 1 is called as? What is this n minus 1 is called as? That is question number 2. These are the two questions, and let us see what is the answers for these two questions. Okay. Cluster clear? Okay, good. Why n minus? First, what is n minus 1? Let us understand first what is n minus 1. N minus 1 is called as degree of freedom. N minus 1 is called as degree of freedom. Degree of freedom is how much freedom you are having to choose, is called as degree of freedom. Okay. For example, I have shown you 3 fingers like this. Out of these 3 fingers, touch 1 finger. I asked you. Okay. Now to touch 1 finger, how many options you are having? 3 options. I have shown you 1 finger only. Touch 1 finger. How many options are you having? That is not called as option, mandatory. That is not called as option. That is called as mandatory. Option means you are having the freedom to choose. That is called as option. If you're not having the freedom, then it is called as rule or mandatory. That is called as degree of freedom. Example. Let us say with an example. So for example, I am having 7 shirts with me. Okay. Assume 7 shirts are there. Shirt number 1, I'm going to use on the Monday. Shut number on Tuesday, I'm going to use on Monday. How many options I'm having to choose one shut? 7 options are there. On Tuesday, how many options you'll have? If you repeat and if you wash, miss 7 options every time. If you wash and I will use service, our service will be 7 only. Every time it will be 7 only. Assume that no repetition is allowed. No repetition is allowed. Means 6 options. On Wednesday, 5. On Thursday, 4. On Friday, 3. On Saturday, 2. Out of 2, 1 you can select. On Sunday, mandatory. You have to use that one. Means every time 1 will be left out with no option. Okay, 1 will have with no option. You have to select. That will not have any kind of degree of freedom to choose. That is called as degree of freedom. Of course, you'll not satisfy with one example. Obviously, you have to ask second example. Explain with a different example. Let us try with one more. X plus Y plus Z is equal to 30. What are the options of X and Y and Z? 10, 10, 10 is one of the option. Did I told everything are equal? That is one of the option. What are the options? 9, 11, 10, 8, 12, 10, 4, 6, 20. Every time positive values are negative values also you can consider. X you can take positive, negative, anything of your choice. How many options are there? Infinite number of options are there. For one equation and 3 unknowns, infinite number of options. Now I'm going to fix one of them, 15. 15. Now how many options you are having for Y and Z? Again, infinite number of options. You can choose anything. Plus 100 minus 85. That also gives you the 31 finally. Y value can be plus 100. Z value can be minus 85. Anything. Okay. Now 15 plus this one I'm going to fix as 10. Now how many options you are having? That is not called as an option. Fixed value. Every time 1 will be having fixed only. That will not have the option. That is called as degree of freedom. 1 will be left out every time, which we used to call as degree of freedom. And that degree of freedom is n minus 1. Every time 1 will have no option. We have to select. Is that clear now? N minus 1 meaning is now. Okay, sir. N minus 1 is called as degree of freedom and it is clear. Now, why we have to consider that one in the population sample? That you tell us. Now, second question. Question number 2. Why we have to consider n minus 1 in the sample? Reason behind that is, now population data is entire data. If 1 is not there also, it is considered as the sample data. If everything is there, then it is called as population data. Minimum 1 is not there also, it is considered as the sample data. That is the reason it is considered as n minus 1. Why we have to consider n minus 1 in that miss? If one data is not there also, it is considered as the sample data. Every data is there, then it is called as population data. Okay. Now, this n minus 1, we have to apply in the variance that n minus 1 logic. That is sigma of x minus x bar whole square. Instead of considering n, you have to go with n minus 1. This was told by the statistician called as Bessel. Bessel is the statistician. His name is Bessel. Okay. He has told that before to that, everyone used to consider n only, small n only. Everyone used to consider small n only. He has told that you should not consider n. We have to consider n minus 1. That is the reason it is called as Bessel correction. Interview question number 3. What is meant by Bessel correction? Bessel correction means considering instead of small n, n minus 1 in the sample variance and sample standard deviation is called as Bessel correction. Bessel has corrected that one. That formula was corrected by Bessel. So it is called as Bessel correction. Clear, guys? If you come in the order, statistics will be the dead easy concept. It is not like max doing the formulas and remembering by hearting, nothing will be there. But the thing is, you have to understand the reason behind that, and that too you have to come in the sequential order. Automatically, the subject will be dead easy. Right? Clear? So that is the end of the session for today, and we'll continue in the next class, that is on Monday. Any questions? If you have any questions or doubts, online students, please write in the chat box. Offline students, you can please ask whatever the questions you have.